And just as a quick refresher, we'll work through the first 3 warm-up problems here. As you can see, our goal is to write and solve algebraic models. And then we'll also look at some error analysis, trying to see where the error was, maybe a common error that students would make. So we'll try and look at that as well. I'm going to give you a couple of minutes, try and give you 2 or 3 minutes here. See if you can complete the 3 warm-up questions. First 2 are simplifying. The third is also simplifying, but it involves a little small word problem. So for the first warm-up problem, if you distribute the -3 through, you should end up with 8b minus 12 plus 3b, and that ends up giving us 11b minus 12. The second warm-up, when you distribute the -6 through, just be careful with those negatives. Combining our like terms, we have the m's that we can combine, and then we have the numerical values. So 8m and then positive 34. Number 3, you bought a pair of jeans for N dollars in a city where the sales tax rate is 5%. Write an expression for the total cost of the jeans, including the sales tax. Does anybody know, do we pay sales tax on jeans in Pennsylvania? Or on clothes, for that matter? Do we pay sales tax on clothes in Pennsylvania? Does anybody know?
We don't.
We don't, right. Do we pay tax on food? We don't pay tax on food either, as long as it's a necessity. So if you buy Pepsi, you're going to pay tax on Pepsi. They don't consider that a necessity. But if you get milk or orange juice, then you don't have to pay tax on that. So necessity items in Pennsylvania, we do not pay tax. A city where you would pay 5% tax, New Jersey? Maybe? I think New Jersey, their tax rate is 5%. I think so. All right, so we buy a pair of jeans. Those jeans are N dollars. The sales tax is 5%. How would we get the total cost of the jeans? Can somebody give me an expression that you found for the total cost of the jeans? Helene, do you have an idea how we would write the expression for the total cost of the jeans?
Would it be total equals N over 5?
So, all right, let's talk about how you got that. How would you write 5%? So how do we write 5% as an actual numerical value? What would that become as a number?
0.05.
Yeah, 0.05. Okay, so we have 0.05. And our jeans are N dollars. So they might be $20 because you got them on sale at Old Navy. They could be $30 or $40 or $100 depending on how fancy your jeans are. I don't spend that much money on jeans, but I know teenage girls do and college girls do. Mm-hmm. Yes. So the jeans, the cost of them, it's already 100% of the cost. So my jeans, whatever that cost, is going to be N. When you have sales tax, does that increase the cost of your jeans or decrease the cost of your jeans? So what does sales tax do? Helene, do you know, would it increase the cost of your jeans, decrease the cost of your jeans?
Increase.
Yeah, it's going to increase it. And it's going to increase that cost by 0.05 times whatever you paid for the jeans. So my jeans were N. In addition to that, I have to pay an extra 5% times the cost of the jeans. So that means our total cost, if I add them together, there's really a 1 in front here, I would have 1.05 times N. That's how I find the cost of the jeans. So I take that cost, I increase it by the 5%. If there was a discount on the jeans, so they were 20% off, then I would decrease the total or the initial cost by that 20% off or whatever they happen to be. So sales tax increases your initial cost of the jeans. All right, so we're going to get to an equation, and it looks like a little word problem underneath. This equation, multi-step problem, solve for x. So just think about the process that you would want to do to solve for x. Faith, what would you do first to solve for x?
You distribute the 3 and the -2.
Yep, there was my cat walking across the screen if anybody noticed it. You were paying attention to your problem, if not. All right, so she said distribute the 3 and the -2. So let's do that part here. Careful with those negative signs. It's a positive 2x and a negative 14. All right, so cleaning up the right side here. I have a negative 10x and a negative 14. And then move terms to one side, the numbers to the other. Jaden, what would that look like if we got a variable on one side and a number on the other?
Sorry, I was still adding.
No, you're okay.
It would be it would be 25x on the one side and 10 on the other side.
Perfect. Nice. So adding the 10, adding the 24, and then divide. So yes, the only answer will be a fraction. If the fraction can be reduced, make sure you reduce it. Don't just leave it as 10/25. So I would reduce this as 2/5. If it happened to be a complex fraction, or an improper fraction, where it was the opposite, if the 25 was on top and the 10 was on the bottom, that's considered an improper fraction. I would reduce that to 5/2, but we're not writing it as mixed numbers. So pretty much once you get to Algebra 2, your answers are in fraction form. We will not be using mixed numbers. So just a little side note there, keep fractions as fractional values, even if it is improper. All right, so a little equation there just to give us a review of solving equations. We had a couple solving equations also on that pre-course worksheet. This example underneath for number 2 is another word problem. This one's a little difficult to think about. And you're going to see a lot of these types of problems on standardized tests. So like the SATs, the PSATs, that type of problem kind of comes up. It's kind of like a rate problem. So it says it takes you 8 minutes to wash a car, which I don't know. It seems like the car wouldn't get washed very thoroughly in 8 minutes. Maybe it's a small car. It takes your friend only 6 minutes to wash the car. So they're not even doing a very good job washing the car because they only take 6 minutes. How long would it take the two of you to wash 7 cars if you work together. So we have a rate that you can wash 1 car, and we have a rate that your friend can wash 1 car. So you're 1 car in 8 minutes, the friend is 1 car in 6 minutes. Combined, how long would it take you to wash 7 cars if the 2 of you are working together? So think about it. We're trying to find how long, so we're trying to solve for time. How much time would it take the 2 of you to wash 7 cars? So we know our variable we can say is t for time. And I'm going to give you a little help here. We're going to take the rate times the time for you, add that with the rate times the time for your friend. And then that's going to be equal to the number of cars. Because we have a rate that you're washing a car, and we have a rate that your friend's washing a car. So it's a tricky problem for sure. So rate is like speed times per minute, or cars per minute. Well, my rate would be 1 car for 8 minutes. So that's like the speed that you're washing the car. I don't know what the total time would be for us to wash 7 cars, but I know that my rate for 1 car is 1/8. If I continue that pattern, my friend can wash 1 car in 6 minutes. Again, I don't know what the time would be for us to wash them together, so I'm going to put a T there. So T would be representing the time it takes us to wash 7 cars together. So I'm going to go over that again. Rate is kind of like your speed limit. That's considered rate. Well, in this case, our rate is cars per minute instead of miles per hour, how a speed limit usually works. And if I take the rate times the amount of time that it takes the 2 of us to wash a car together, and I add the 2 rates together, I should be able to figure out how much time it takes to wash 7 cars. Now I'm going to try and solve this equation, and it has some fractions in it because we have this rate value. And an easy way to get rid of fractions, instead of finding a common denominator and converting these, just keeping them as fractions, we're going to use a common denominator to help us eliminate the fraction. So if we have 1/8 and 1/6, does anybody know what the common denominator would be between 8 and 6? What would the common denominator be? Madison, what would the common denominator be?
Would it be 24?
Yeah, it would be 24. So what I'm going to do is I'm going to multiply everything by 24, each piece, because I'm going to try and get rid of the fractions instead of keeping them in the problem. So if I take 24 times 1/8, that becomes 3. And if I do 24 times 1/6, that becomes 4. And then on the other side, 24 times 7, I have to do the same thing. I'm doing this conversion. If it's an equation, the same thing to every piece. That would become 168. Now, notice when you add these together, it ends up being 7t. That's just purely coincidence that we happened to start out with 7 cars, and when we added them together, we got 7t. If I had 10 cars, it wouldn't be equal to the same value. And then we divide by 7. How long does it take you and your friend to wash 7 cars? Jordan, what do you think?
24 minutes.
Yeah, nice job labeling it as well. How clean do you think those 7 cars are, Jordan, in 24 minutes?
Not very clean.
Yeah, probably not. Maybe you're not drying them off and you're just like giving them a quick wash and hosing them down. Has anybody
Yeah.
done a car wash before with maybe your sports team? No car washes? I know it's a typical thing. I feel like the band might do a car wash or maybe the cross country team. Maybe not this year. Maybe in previous years, but I don't know. 7 cars in 24 minutes. That seems super speedy. Any questions on that? So we are going to continue and do one more problem. And if you look at the top, actually we're going to do, it looks like maybe we'll do A and B and we'll save C and D for tomorrow. So example 3 at the top of the next page wants you to rewrite and solve the equations. So now we have equations that have multiple variables and they're asking us to rewrite it. Rewriting just means rearrange the equation for whatever variable they're asking us to solve for. So in letter A, it says solve the formula P equals 2 times the length plus 2 times the width for W. So we're going to stop at that part so that we answer that first part. Solve the formula. This is the perimeter formula for a rectangle. We're going to solve it for W. So 2 times the length plus 2 times the width. That means we need to get W by itself. Cody, what do you think you do to get W by itself? Maybe. So how could you isolate the 2W? What could you do to isolate this? What could you take to the other side or move away from it? Does anybody know? How could you get 2W by itself? Madison, how could you get 2W by itself?
Would you divide it by 2 and then divide it by 2?
We will divide it by 2, but before we divide it by 2, what do you think we need to move to the other side?
2W, or would you move, over to the other side?
We're going to move
So
2L to the other side. So we're going to get this away from it first. So our goal is to get that W term by itself. And in order to do that, we need to move the other term away from it. So we're going to subtract the 2L to the other side. So now we have P minus 2L equals 2W. So anytime you're trying to solve for a variable, if there's another variable on the same side, we need to move that other variable away first. So we're kind of taking that other variable away from the 2W. And then I heard that we're going to divide, and we are going to divide. We're going to divide that whole thing by 2. So you actually divide last because that's the coefficient that's directly attached to the W, and that really is the last thing we would do to get W by itself. So now the width is equal to P minus 2L and then divided by 2. And we can keep it like this. We don't have to individually separate that. The second question says, find the width of the rectangle if the length is 12 meters and the perimeter is 41. So how wide would this rectangle be? Well, perimeter is P, length is 12, and then I would divide that by 2. So this is just a different way of solving for the width. Usually we're thinking about perimeter. Perimeter is 2 times the length plus 2 times the width. But we can also think about it as solving for the width instead of focusing on the perimeter. So 41 minus 24 divided by 2. Anybody know what the width would be equal to? Don't forget your label. So who has the width of this rectangle? Brooke, what do you have?
The width is 8.5 meters.
Perfect. And she remembered that label. All right, we're going to just wrap up this last problem here. Again, solve the equation for y. So we're going to do exactly the same thing, solving for y, using the same process that we did above. So we want to move the other variable to the other side. We're not worrying about y right now. We're going to take the 9x to the other side first. So you always move the different variable. Get that away first. So we have negative 4y. Negative 9x plus 7. And then we would divide by negative 4. Now this problem, because this is slope-intercept, it has an mx and a b. We will be rewriting this so that it is in mx plus b form. So that really means that I'm taking the negative 9 and dividing it by negative 4, and the negative 7, or the 7, and dividing it by negative 4. So that would be what my slope-intercept form of the equation would look like. So it kind of depends on what you're solving for, how you write your equation's answer. So we're going to stop there for today. Tomorrow we'll go through a couple of more problems trying to rewrite variables. Again, the homework assignment is not due until Thursday. So it's practice 1-3 and 1-4. They're both posted in the same assignment. Just do the evens. I think some of you did all of the problems from last night's homework, which is okay. You just got extra practice. But I don't need you to go crazy with the problems. Trying to make sure that we get enough practice in, but we don't need to do a lot of excessive problems. So tomorrow we'll wrap up this section. We'll do a couple more examples, and then hopefully you'll have some time to get some of the problems done in class. Are there questions before you leave for today? All right, good luck with your second day. Thanks for joining me today. Have a great day. Looks like a good number of them had their cameras on.
Yeah,
Yeah.
definitely one yesterday.
Yeah. Did you see my girls come down at all?
I did not.
No.
Were they on?
I don't know. They were still sleeping.
I was like, did I miss that?